Hello everyone, hope you're doing good. Welcome back to my channel. Today we are at day 16 of the December daily LeetCode challenge. Before I begin this question, big congratulations to all of you who have maintained their pace till now because we have completed the first 15 days of the December daily LeetCode challenge and today is the 16th day. From here onwards, we have around 15 days more remaining for this challenge and after that we are done with 2024 and yeah, that's will be all for 2024. So if you have been consistent for this much, like let me tell you, we have seen some very good questions in this December daily LeetCode challenge. So like mostly we have same medium questions till now. Till now, we have not seen any hard question in December daily code challenge. But even the medium ones, some of them are very good, and yeah, some of them were on the easier side. Okay, so that was all the summary of the questions that we have seen till now. Now coming to this particular question, like see, this is again, as you can see, it's an easy question, and the constraints will also tell you the same story. And let me tell you this: you can solve this question with your brute force approach also. Okay, so it's pretty much yeah, you can go for n O of n into k approach, and you can solve this question. So like if you want to try, you can pause this video and try the brute force approach first. Okay, in this particular video I will give you the hints that you can try for the brute force. At the same time, I will be showing you the most optimized approach and I will be showing you three variants of the most optimized approach. Okay, I've created three variants of it and I will be showing all the three. Okay, so that will be the summary of, that is, you can say, the index of this particular video. So let us quickly begin. It is question 3264, final array state after k multiplication operations, and this is the part one of that video. Okay, there will be a series of these questions on this and this is the part one of that. Okay, and if you see basically what we are given an integer array. Okay, they are calling it nums, and then we are given a k value. This k will tell me like how many iterations will I will have to do. Okay, see, I'm first of all giving you the gist of this question. Okay, after that we'll go and read the question in detail, and this is the multiplier basically. Okay, why it's called a multiplier? Because we'll have to multiply the smallest element in nums with this. Okay, so that is why they have given it, and this is going to the number of times we have to do this operation. Okay, and this is the nums array. So let us quickly see what it is, and remember one thing: at last we'll have to return the same nums array after all the modifications. Okay, as simple as that. So let's see the question now. You are given an integer array nums and an integer k and an integer multiplier. Okay, you need to perform k operations on nums, and in each operation you have to do the following. Okay, so first of all, you be very clear, you have to do 5 operations in this. Okay, as simple as that. K operations. Now each operation is going to be these two steps. Okay, what are that? Find the minimum value of x in nums. If there are multiple occurrences of the minimum value, select the one that appears first. Okay, that is, they're saying if, let us say, there are, for example, let us say 5 is the smallest value in nums, but 5 is present in multiple indexes. So you will have to choose the index which has the smallest value. That is the index which comes first. You'll have to take that, take the 5 in that index and then do the rest. Okay, so this you have to do there. Replace the selected minimum value x with x into multiply. That is, you have to take that number, multiply it with the multiplier, and then store this new value in that same index. Okay, we'll see it in demo in example one, but this is the requirement of this. Okay, so these two steps will comprise the operation. Okay, what is the operation? Take the minimum value present in the minimum index. Remember, when we are talking about the minimum value can be present multiple times, right? But it will be with a different index each time. Okay, let us say it's present at index 0, index 5, index 10. So we have to take the value which is present at index 0 because that appears first. Okay, as simple as that. That's why they're saying if multiple occurrences are there, you'll have to choose the minimum value, select the first appearance of that minimum value. Okay, first appearance basically means the value with the smallest index, as simple as that. And then multiply that particular value with the multiplier and then store, replace in the same index, store, that is, replace the original value with the new value. Okay, as simple as that. Return the integer array denoting the final state of nums after performing all the key operations. So let us quickly see the example one. See, this is the example one. If you see here, we have to do basically 5 iterations, and each iteration we have to find a minimum element multiplied with 2. Okay, similar that. Let us see. So as you can see, 1 is the smallest value here. So in the iteration one, what we have to do? Take this one, multiply it with 2. So it will become 1 into 1, which is 2. So if you see after iteration 1, this element becomes 2. Now, if this is the particular array, in this which is the smallest element, see, the smallest value is 2. But 2 is present in 2 indexes. So which one we have to choose? We have to choose the one which is present in the minimum index, which is this one. So multiply this with 2, it will become 4. So you can see it is becoming 4. Now, which is the smallest value? This is the smallest value. So this will also become 4. So this is the value after iteration number 3. Now, which is the smallest? 3 is the smallest. So 3 has to be multiplied with 6. So it will become 6 here. Okay, now which is the smallest? Now the smallest is 4. 4 is present again 2 times, so we'll have to take the one which is the having the smallest index, which is the 0th index we have to take. Okay, 0th place. Okay, so we have to multiply this with 2, it will become 4. So this is going to be the final answer. We have to return this as the answer. Okay, after the k iteration, that is after 5 iterations, what is the value that we'll have to return here? Okay, as you can see. And yeah, example 2, it's exactly same, so I'm not going through details of it. You can go through it. Basically, like LeetCode has done a good work here. They've given a very detailed example, okay, very, I can say, readable example, okay. The word readable makes a lot of sense if you have been in LeetCode for a long time, okay. Remember that they are giving good examples, but they are not readable at times, okay. That's why many users have written comments on that. But yeah, slowly they're improving it. That is something good. Fine. Now coming to the constraints, see here, the length of the nums is going to be up to 100, and the value of k is going to be up to 10. Remember, if you're doing this Python, so this will not play a role here, because we need not worry about the data type, okay. In Python, you don't have to worry about the data type, okay. That is taken care by the compiler itself, okay. So that is the best part of Python, right? But yeah, if you're doing this in let us say in Java, other type, whatever you do is just remember what can happen max, okay. This particular number can be multiplied by itself, okay. That is, there are, see, the multiplier can be up to 5, okay. That is, this particular number can be multiplied in the with itself up to 5, that is up to 10 times, okay. So what is the number going to be? 5 into 5 into 5, like that, okay. So what you can do is take 5, okay, 5 raised to power 10 by raised to power 10, because the number same can multiply itself, okay. Simple as that. So 5 raised to power 10, whatever this value, that should be multiplied with this, and then whatever value comes, that is going to be the max possible value that you can get in the worst case. So you will have to decide the data type based on that, okay. I'm just giving you a idea of what you have to do if you're using Java and Python. But yeah, for sorry, Java and C++, but yeah, for Python you don't need this, okay. See, this is the max value of the multiplier, right? You can up to multiply up to the value of 5. Now the case 10, that means, for, let us say, we have an array of only one element, so let us say the value is 100 here in this case. Then what will happen is 5 will be multiplied to this particular value how many times? At max it can go to 10, okay. That is 100 into 5 into 5 into 5, like that, 100, that is around 10 times, okay. So what you can do is, yeah, take 5, make it raised to power 10, and whatever is the value that you should multiply with in this one. Then what is the result? That is going to be the data type. That is, for this is going to be for your estimate, okay. So what is the value coming? That is the max value that can come in this whole answer, okay, this whole question. So you have to decide the data type based on that, okay, fine. And as you can see, the case value is very less, and this value is very less. So basically, you can try for a brute force approach where you can go for an n into k, okay. If this is the n and this is the k, you can go for n into k solution also, okay. We'll discuss about that also, fine. So how then n into k solution will work? See here. First of all, you have to find the smallest value. For finding the smallest value, you have to loop in through the whole array, okay. That will take O of n time, right? That you need to do for uh, k times. So for each iteration, that is for each k, go throughout the loop and find the minimum value, then multiply it with k and replace it, okay. So that will take n into k time, okay. That is going to O of n into k solution. But I will be showing you using the heap, okay. Why I'm using the heap, because see, the idea is very simple. We always need the smallest value only, okay. So for, see, many will say, why you are not sorting? See, sorting will be something very primitive here. The requirement is very clear. We only need the minimum value in each iteration, okay. I don't have to sort the rest of the values. So for this particular requirement, the best data structure is heap, because heap will give me the only the minimum value at a time, okay. And I don't have to waste my compute power, my time power, that is my available time, on sorting the rest of the stuff, okay. So for that reason, heap is the best. Now let us see the solution for it. So first of all, I will show you the I can say the variant number 1 of the solution. Then we will see the other two variants as well. Okay. See here, I'm declaring a heap. Okay. And then what I'm doing, I'm just capturing the the length. Then fine. Then I'm going through. Basically, I'm trying to fill this heap now. Okay. With what I will show you for each. Basically, I'm going through each of the element in the nums, and then I'm going to insert this particular element in the heap. Okay. For each element in nums, this element will be inserted. So what is this element? See, this whole thing is going to be a single element in the heap. Okay. So a single element heap will be comprising of two terms. Okay. The number, the nums value itself, and the index of it. Okay. Why I'm storing the index, I will show you now. See, the idea of storing index is, for example, see here, for example, you have these two values, okay. So if you are storing the index, that will act as a tie baker. Remember that. By C, the value 2 is here also, the value 2 is here also, but we want the value, if the two values are same, we want the value with the minimum index to be there in the top. For that reason, we need a tie baker, okay. So in this case, the index is going to act as a tie baker. For that reason, we are also storing the index. If you see here, this element is this is a single element. Basically, remember that is a single element in my heap. This is the second element in my heap. But what is happening is, both of them are having a value 2, okay. So the tie baker is going to be the index, which is why I'm not storing the index also. The value with smallest index should be there in the top, okay. That is the basic idea of using this thing, okay. That's why my element will look like this. Fine. Just next, what I'm doing, see, then I'm just printing the heap for you. Printing part, you can just comment it out while you're segmenting, okay. Remember that part. Then what we are doing, we are starting a loop, basically. There is, it's going to be k iterations. In each iteration we are popping the value, okay, we are popping element out of the heap, okay, then we are checking, okay, what is, see, these are the two things that will pop out, okay, in a single element of heap. Basically these are the two values, okay, fine. Then we are multiplying the value with the multiplier. We are going to the index in nums and storing this value there, okay. Then we are again pushing the new value, okay, we are pushing the new value. What is the new value? The new value is going to be this, okay, the value multiplied with the multiplier is going to be stored here, and the index will be stored as it is, okay. So the previous value was like this, the previous value is like this, the new value is again the same, but in this case the value is already multiplied with the multiplier, that is again being inserted there, okay. And finally this will keep continuing for k iterations, and after that we return the nums, okay. If you see here, we are updating the nums in between, so that's why we can directly return the nums without worrying about any other updation, okay. So I've already segmented this solution and it works the best, okay. Now discussing the space and time complexity of this. See, time complexity is going to remain the same for all three variants that I'm going to show you. We are using a heap, which is going to be array. In this we are going to store n elements, okay. So the time is always going to be of n only, not coming to the time, that is, yeah, sorry, the space is going to be always of n. Now coming to the time complexity. See here, basically for each, this is going to run for n iterations, and in each iteration we are basically making a push is going to take O of n time, okay. So totally how much time we are spending on this loop? We are spending n into log n time, okay. So this part is n into log n time. And similarly, if you see here, there are k iterations here. In this, in each iteration basically we are doing a pop and a push. So let us say, like, see, each pop and push will take log n time, but since both of them are there together, we'll take only once, because we have to see the upper limit, right? So only once we'll take. That is, in each iteration we are doing log n time, okay. How many iterations are there? There are k iterations. So this whole thing is going to take k into log n time, and this whole thing is going to take n into log n time. So the total time complexity will be n plus k into log n, okay. This is going to be the time complexity. Fine. How to decrease it? See, I will show you one good thing here now. See, if you understand the implementation of heap, you will understand that, see, when you are pushing a element, basically the heap structure is changing in between, okay. That is, there are some calculations happening there, there are some modifications happening there. That is, see, the heap is basically binary tree, okay. Whenever you're pushing a value, it will be there in the leaf, and then it will slowly be pushed up, upwards based on their value, okay, the comparisons and all that, okay. So the idea here is, why you want to do the comparisons while you're inserting the value, okay. So to avoid that, there's a good approach is here. See, what I'm going to do is the same solution, exactly same solution, but the only thing that is going to change now is, see, here, instead of doing a push, what I'm doing first, see, in the heap itself, I am appending the values, okay. I am appending the values as it is, okay. Appending is a of one operation, remember that, okay. Open the constant operation. After appending all the operations, I am now going to use heapify function, okay. In the previous one I did not use the heapify function, okay. So that's why it is going to take n into log n time, this part. But if you use the heapify function for the same purpose, that is, remember, we have just appended the value, it is not sorted currently. So to initialize the heap, that is to initialize the data sector of the heap, basically you have to run the heapify function, okay. If the array is already filled, if the array is not empty, in that, if you want to build that data structure, you'll have to run the heapify function. Heapify function is much better than pushing. See, here the same thing, there are n elements, I'm going to make it as a heap, but it will take basically O of n time, remember that. It will take O of n time, but in the other case we took n into log n time, okay. So that is the difference. So you should not use the the push. Basically, if you are knowing what is the value going to be, you first insert them in the list or whichever place it is, and then just use the heapify function, okay. So this loop is going to take O of same thing, like, this is also going to take O of n time. This is also going to take O of n time, and this I already discussed is going to take k into log n time, okay. So the total complexity in this case is going to n plus k log n, okay. So basically in the other solution, what was it? K log n was same, but here it was n into log n, but here we reduce it to only n, okay. So that is the advantage that we are going to get now. This is going to take O of n time, this is going to take O of n time. In the previous one, these two steps were combined, but in the together it was taking O of n into log n time, okay. So that is the advantage. Now one more place where we can add, do optimization is here. See what we are doing here. See, that's why always I say, like, please open your eyes, okay. Please take ideas from everywhere, okay. These things will play a lot of role. Let me tell you this. Even if you are showing this much variance, okay, in your interview, let us say you are having only one solution and you are showing even this much variations, remember this will also be treated as optimization, okay. You are able to optimize the solution. So though these are not very drastic optimizations, but still they are optimizations. If you see the, basically if you compare your solution to runtime, you can see that there are differences coming, okay. As simple as that. Fine. Now what is the second optimization is going to be? See, this is the third optimization. See, now in the each iteration, basically what you are doing is, we are doing a pop and we are doing a push. See, doing this individually is not a good idea. Why? I will tell you that. See, if you are understanding how the implementation works inside of heap, you will get to know that this is not a good idea, okay. First you are popping a value. When you pop a value, what happens? The top of that is root of the heap is popped out, a leaf node is taken there, replaced there, and then the comparison starts, okay. That is not a good thing, okay. And when you push, the same thing happens again. Something is append as a leaf node, and again the comparison starts. So basically the comparison is happening for two times, which is not a good idea. So there is the option, if I can show you, this is the one, okay. So what if you see here, see, this is the idea. There is a function called heap replace. So what it will do is it will pop the value, at the same time it will insert a new value. Okay, so you will ask me, like, if I am popping and see, I need the popped value, right, to do all these calculations. How I'm going to do that? See, instead of popping it, you can just take mean heap of zero. That is, you can take the same values in the zeroth index. Whatever is the zeroth index, that will pop, right? So you can use the values as it is, okay, without popping it. And at last, when your value is ready to be inserted, okay, when your value is ready to be inserted, that time you can use the heap replace function. Okay, heap replace function, what it will do is it will pop the value, at the same time it will insert the new value. This works much better compared to a separate push and a pop operations. Okay, you can see the documentation of the heap library. Okay, in that it's clearly mentioned. I did not open that here, but it's clearly mentioned in that instead of doing heap, that is, yeah, pop and push together, there is an option called heap replace, which works much better than the combined. Okay, if you're using them separately, heap, push and pop, combined, you can replace them with this heap replace function. It is doing the same work as them, but it works much better. Okay, because here you are not doing the two time comparisons. Okay, a single value is, that is he root is popped, and in the place of root, a new value is inserted, and the only one time the comparisons are happening. Okay, so that is the advantage here. So yeah, friend, that was all for this particular video. These all are the three variants. You can try them out. Okay, in each one I showed you some optimizations. Okay, and I also discussed about the brute force approach, which will O of n into k. Okay, so you can try that also. So this was on the easier side. That's why I wanted to show you much, something extra, so that you are sure. See, remember one more thing: when you are in CG question and you are using a data structure, be very good in the actual understanding of the data structure. They can ask you to draw a binary tree to show how the heap functions when a node is pushed, when a node is popped, how the internally the calculations are happening inside the heap. Those things will be asked if you're getting easy question. Remember that. So be very good in them, in the like how these structures are working, because see, DSS, this is what DSS, right? DSS is not just problem solving, but also how the data structures are built. Remember that part. So you can show multiple variants. These are treated as optimizations. These are treated like they are considered very good. Remember that. They will keep a this will they will see, there will be markings, right? You are able to optimize the solutions. That is something that will give gain a lot of attention, as simple as that. Fine. And other than that, yeah, you should be aware of how the data set functions, because see, you should not waste any of the time in your interview. You should have something to talk about. So if you have something to talk about, the interview will be in your side. Okay, as simple as that. So yeah, and that was all for this particular video. And we had a contest on Sunday, like the last Sunday on the 15th of December. So I uploaded the solutions for that. Please do check them out. Okay, there were really some good questions in the Sunday's challenge. So please do check them out. You will get a lot to learn from them as well. Okay. So yeah, and that's all for today. See you tomorrow.